This is Miss H once again, coming live and expressing to you how to solve systems of linear equations when we're solving for three variables, using specifically elimination. Let's begin. The first thing we're going to do is look for the variable with the least work. We don't want to do a lot of work here. We see we have the equations, we see the variables are all lined up on one side of the equal sign. They must all be lined up on one side of the equal sign. Now we're going to look to see what we can eliminate easily. Okay, in the x's we have x, we have 3x, we have 2x. Now that's going to be a little work to make something the same so that we can eliminate the variables and then be able to solve for this. The y's are kind of difficult also. We see two y's are the same, so that will be easy. But still we're going to have to do some multiplication here. But look at the z's. All of the z's are 1z. That means I would have no work to do. Absolutely no work at all. So the first thing you have to do is try to find the variable that's the least work. Okay? Now I would probably eliminate my z's first, and that's what I'm going to do for this problem. Okay? Some of you always go towards the first variable and you want to eliminate the first variables at all times. That's fine also if you choose to do that. Okay? But in this case, I think I'm going to eliminate the z's. Okay? And then maybe in the next video, I'll show you how to eliminate the x's so that this way you can see the procedure. Okay? So here we go. First thing it says, once you decide which equation to use, I'm going to use 1 and 2. We're going to write down 1 and 2. So here we go. X minus 2y plus z equals 7, and 3x minus 5y plus z equals 14. And this is question number 1, equation number 1, and equation number 2. Okay. Now, we look at the z's and see what symbols they are that are in front of the z's. This is addition and addition. Now, if I said I want to eliminate these two z's, what do I have to do to the two equations so that the z's will cancel out? If I add them, I would have 1z plus 1z. That would not work. That would give me 2z. But if I subtract the two equations, by subtracting the two equations, I have now eliminated, there it is, I have eliminated, and I can eliminate my values for z. Now watch. This would be 1 because there's no number represented, so that would be 1 minus 3. Now let me see, 1 minus 3. That's a positive 1 minus 3. That would give me a value of negative 2x. Now let's go on. This would be negative 2 minus a negative 5. Now a negative and a negative become a positive, so that's like saying negative 2 and a positive 5. So that's a positive 3y. Then we have the z's. A positive 1z minus a positive 1z. We know that's going to cancel. 1 minus 1 is nothing, 0. And then we have at the end 7 minus 14. 7 minus 14. That means that this is going to be like a negative 14. Let me see, 7 positives minus 14. That would give me a negative 7 as my answer. Okay, and we can do these problems on the side or on the top or on the bottom or somewhere. Notice, 7 minus 14. So that's a positive 7 minus 14. Now what normally happens when you have integers? You change the sign. We studied this and it becomes a negative. We studied this in another video. So circle and circle, that means we have to subtract the numbers. That's 14 minus 7 is 7, and we keep the sign of the larger negative 7. just to review that a little. I'm not sure if you can see that, so I'll just trace over it so you can see. We have to subtract them, remember. That's a negative 14. There it is. Change the operation sign, all right? That's how we did it before. So we end up with a negative 7. Not sure you can see it. Why? Because when we subtract the numbers, we end up with 7, and we keep the sign of the larger number, which is negative in this case. Okay, we did this in another video. So if you have to look back at that video, it will help you out a lot with the integers. Now, this is the equation that we have at this point. Now, if you notice, it says, do the same for, let me move it up for you so you can see, do the same for equations 1 and 3. So we're going to take equation 1 and 3. We have 1, 2, 3 equations. We're going to take equation 1 and equation 3 and do the same exact thing we did here. Eliminate the z's. Okay, so equation number 1 is x minus 2y plus z equals 7. And equation number 3 is 2x minus 2y minus z equals 3. So now let's take a look at that equation, those two equations, and see what's going on and what's going to happen. If you notice in z's, one is a plus and one is a minus. Now with plus and minus, how do we eliminate those? Well, positive 1 plus a negative 1. Oh, those would cancel out. So that's what we're going to do. We're going to add the two equations. We're going to add the two equations. And by adding them, that will eliminate the z's. Watch. So look, 1x plus 2x. Remember, if there's no 1 represented, there's actually a 1 there. We can fill it in if we like. There's a 1 there. Okay? It's an imaginary 1. It's there. It's in the problem. We can't see it. But we have to know that variables without a number have a 1 in front of it. So 1 plus 2x. That's 3x. 2y, that's a negative 2y. A minus 2y plus a minus 2y is a minus 4y. Now look at this. Positive 1z plus a negative 1z or minus 1z, that would be nothing. That would be eliminated. And what about this? 7 plus 3 equals 10. So now we have two equations. We have the one above and we have this one. So we have two equations, two wonderful equations. Let me show you the two equations so you can see them. We made ourselves two equations. Now, instead of solving that big problem that we had with the 3 equations all over the place, now we have two equations with this 2 variables. So that should be easier. Place the two equations together. That's what it says. Let's place them together. It says place them together. We say negative 2x plus 3y equals negative 7. That was the first equation. And now the second equation, 3x minus 4y equals 10. I hope we're okay so far. Good. Look to see which variable can be eliminated. Well, let's look at it. If we look at it, we notice that none of the variables are the same. They're all on one side, which is what we want, but none of them are the same. So we say to ourselves, well, what can we do to make them the same? Well, I'm going to go with the first variable, the x. If I multiply 3 to the equation on top and 2 to the equation on the bottom, guess what? I end up with 6x, equations that look exactly the same. So that's what I'm going to do. I'm going to multiply the top by 3 and the bottom by 2. And I'm going to put a dashed line so you can see that we're changing the equations. We're literally changing the equations on our own to help ourselves out. Now watch. If I do that, I end up with negative 6x plus 9y equals negative 21. So all I did was distributive property. I multiplied everything by that 3 on the outside. I'm going to do the same thing to the bottom one, but I'm going to multiply this time by 2. If I do that, I end up with 6x minus 8y equals 10. Oops, 20. Because remember, we're multiplying 2 times 10, which is 20. How are we doing so far? I hope we're doing well. All right, now we can put the two equations together. If we put the two equations together, we end up with something wonderful. Actually, quite nice, actually. It works out perfectly for us. We end up with, let's see, now how are we going to put these together? We have to decide, are we going to add or are we going to subtract the two equations? So it's always adding or subtracting the two equations at this point. Well, one is a minus and one is a plus. Let me see. To eliminate that, we have to add. If we add the two equations, we will end up canceling out the x's. So, -6 plus a +6, that will cancel. +9 or plus 9y plus -8y or minus 8y. So that looks like this. Let me just show it to you right here. +9 plus a -8. And we did this once again in another video. Circle, and you end up with a +1, you see. So 1y. Or you could put +1y. Either way is fine. Now, minus 21 plus 20. Same thing. The signs are different. We have to subtract the numbers. We get a 1 and keep the sign of the larger, which is negative. So we have, basically, if we divide 1 to both sides, and I don't think we need to do that, but I'll show it to you anyway, y will equal -1. So we have our first variable right there. Y equals -1. Now what are we going to do? What we're going to do is we're going to take that y equals -1, and we're going to place it into one of the two. It says solve for the first variable. So we did that. We solved for the first variable. We're going to take that variable, which is y equals -1, and we're going to substitute it into one of the two equations that we made. Remember, we made two equations, this one or that one. We're going to substitute it into either one you like. I like the first one, so I'm going to stick with the first one. If you want to substitute it into the second one, you can. It will give you the same result. So we're going to write down, I'm going to write it right here. -2x plus 3y equals -7. All right, and I'm going to remove this paper for just a little bit. Substitute the found variable into one of the made-up equations. That's what we did. Now, here we go. -2x, we don't have the x, so we can't substitute that. 3 times -1, that's our substitution right there. We just substituted in. There it is. That's what we're substituting in. We just substituted it in. Equals -7. So let me ask you a question. What is 3 times -1? Isn't that a -3? And I'm going to rewrite everything so I can see what I'm doing. Let's keep going. Now we add 3 to both sides because we're basically solving the equation. So we end up with 2x with the negative. This cancels, and we end up here with -7 and a +3. What's a -7 and a +3? Even if we use our fingers, we can figure that out. You know, you have to subtract the numbers, so you end up with 4. And you keep the sign of the larger, which is a negative. Now, how do we solve -2x equals -4? We divide by -2. Divide by -2. X will equal just 2. Remember, a negative dividing a negative will give you a positive. A negative dividing a negative will give you a positive. So right now we have the value for x also, which is 2. Okay? So now we know our y and we know our x. Our y was -1 and our x was 2, or is 2. Now, after that, we're going to take the two variables now and substitute it into one of the original equations. These are the original equations, the 3 that we started with. So we're going to substitute them into one of these equations, any one of your choice. I'm going to choose the first one. I usually go with the first, so I'm going to choose the first. Okay? So we have x minus, I'm going to put it right here so you can see that I'm copying the same question, not something different. 2y plus z equals 7. Now, why exactly am I copying this one instead of one of the two that I made up? The reason being is because, remember, in the other two, we only have x and y. We have now x and y. If we substitute that in, all it's going to give us is what we have already. But if we take these two letters and numbers and substitute it into the original, we'll be able to find our last variable, which is z. Okay, so let's go for it. Here we go. So here, substitute, that becomes 2. I'm substituting right here so you can see it. I'm putting a parentheses around it. That's my substitution. Right there is my substitution. Minus 2, and I'm going to substitute here a -1. I want to show you that I'm substituting here a -1. Okay, plus z, that's the number we're still looking for. All right, and I want you to see what I'm doing, so I'm going to move up just a little bit. So I substituted here a 2, and I substituted here a -1 so that you can see. Okay, and let's keep going. So this remains 2 minus, what is this? Wait a second, this is -2 times a -1. Now, if the signs are the same, let's treat that like it's an integer because it's like it's an integer. So this becomes a plus. Do we see that? That's like saying plus 2, just like that. Okay? Plus z equals 7. Now, what is 2 plus 2? We know that one. That's easy. 4 plus z equals 7. Now, let's see. How do we solve so that we just have the z by itself? Well, we've learned that a long time ago. We take the inverse of what we have. If this is plus 4, which any number without a sign is a positive. If this is plus 4, we take the -4 and we do it to both sides of our equation. That will cancel, giving us z as our remaining number. What is 7 minus 4? 3. So that means z is the value of 3. So we have, right now we have these values. 2 is x, y is -1, and z is 3. X is 2, y is -1, and z is 3. Now, we are not quite finished yet. Let me tell you why. Because we still have to do something called check. We need to check all these values to make sure they are correct. Now, let me note a couple of things before we do our check. I want to just note a couple of things. I'm going to write the numbers in. This is what we ended up with. But I want to talk about this first. Remember, to complete all checks so that you make sure that the variables all work. Because sometimes you can check 1 or 2 equations and they'll work fine, but then really on the third one, it doesn't work. So that means something went wrong. Okay? When you substitute in the variables into all, you prove that they work for all of the equations that you started with, the original equations. Okay? I want you to remember this also. If the signs are the same when you're trying to do the elimination of the variables, you subtract. Okay? Subtract. That means if there's 2 negatives or 2 positives, you will subtract the 2 equations and you'll be able to eliminate that variable at the time. If the signs are different, I want you to add the equations when you're trying to eliminate. See, when the signs are different, if you add them together, they'll eliminate themselves. You see, it makes sense. These things I want you to remember just to keep it in mind when you're doing these problems. I also want you to try this problem on your own. Don't look at it. So when you begin all of these things that I'm going through with you, I want you to shut off the camera or shut off the video, try it yourself, and then watch the video so that you know that you're assured of doing it right and correct, and that you have a confidence when you come to the examinations. Okay? So now let's do our check because we have to do our check. We have no choice. Okay, here we go. I'm going to substitute here with my 2 minus 2 times -1 plus z is 3, so I'm going to substitute my 3 there, equals 7. Well, let's take a look. That gives me 2. This is a minus or a negative and a -1. So -2 and a -1 gives me a +2 plus 3 equals 7. I want you to notice that when I'm doing the check, I write my original and then I substitute in. You should be doing the same thing at all times. Never take shortcuts. Shortcuts lead to wrong answers and wrong results, problems. So just do the whole thing so you can see it. 2 plus 2 is what? 4 plus 3 equals 7. I did what they call orders of operation. I went from right to left, or left to right, and I did what I was supposed to do, left to right. We always go left to right and do the work, okay? And what is 4 plus 3? 7 equals 7. So that one checks out. So 3 times 2, let's do the next one, minus 5 times negative 1 plus 3 equals 14. Now I'm taking my time with this so that you can see. So I know the video is going a little bit long, but that's okay because I'm assured that you will understand every step. Once you become familiar, you will see it will go much faster than this. What is 3 times 2? 6. What is a negative 5 and then minus 1? That minus 5 and that negative 1, that's a positive 5 plus 3. So here we go. What is 6? We're going to do orders of operation, so we must go from left to right. That's what we must do. Negative, let me see, 6 plus 5, that's 11. Plus 3 equals 14. Well, guess what? 11 plus 3 does equal 14. This is how you do a proper check. So let's learn to do a proper check so we're not doing half of a check. No good. Here we go. Last one. 2 times 2 minus 2 times negative 1 minus 3 equals 3. Well, let's check this out. This is going to be interesting, I think. I think it's going to be very interesting. Like, so make sure we have everything right. We have everything correct. Yes. And make sure we copied all of our equations correctly, because if you don't copy the equations correctly, I have to tell you, you end up with the wrong answers. Here we go. 2 times 2 is 4. This is a minus 2 and a negative 1. That gives me a positive 2. And then it says minus 3 equals 3. So I could have put this in parentheses so you can see that. That's where the substitution was. What is 4 plus 2? 6 minus 3 equals 3. That's orders of operation right there, what we already know. 6 minus 3 is what? 3 equals 3. And there goes your check mark. We have now concluded and completed systems of linear equations using and solving for 3 variables. It is a process, but it's something that's valuable and something that you can do. I will be doing more. If you request more, I will definitely be doing more of these types of videos to help you out. I hope this helps you. This is Ms. Hollingsworth signing off. Have a wonderful day.